Hello everyone. In today's problem, we have to find the minimum number of operations to make array values equal to k. So let's see the problem. So we are given an array of numbers and we are also given a k value. So in this case, k is equal to 2. Then we have to return the minimum number of operations so that we can convert all the elements equal to 2 or k. If that operation is not possible, then we will return -1. Now let's see what is the operation. So in the array, uh, if we take any integer h, which may not be part of this array, then h is called valid if all the values in the array that are strictly greater than h are identical. For example, in this case, we have 5 occurring 3 times. So any value less than 5 and more than second largest value. So maybe in this case 4. If h is 4, what are the values that are larger than 4? These are 5, 5 and 5. So all the values larger than 4 are equal. If let's say we take h equal to 3, then what are the values larger than 3? These are 4 and 5. So these are not equal. But if h is 4, larger values are equal. So h is valid and this 3 is invalid. 4 is valid, 3 is invalid. So we have to select a valid integer and we are allowed to convert all the larger values equal to this valid integer. So we are only decreasing the value. So this is the only operation that we can do. And we have to try to make these values equal to k. So we have to minimize that operation. So let's see an example, then it will be more clear. So let's say here k is 2. So first what we will convert, uh, we will convert, we will take some value h equal to 4 and convert, we are allowed to convert all the larger values and that should be equal to this h. So 5 becomes 4, 2 remains as it is, this 5 becomes 4, 4, 4. Now uh, we can take 3, h equal to 3 and convert all the 4s to 3. And why is that? Because if we take 3 here, what are the values that are larger than 3? Those are 4. So all are equal. And then in the next step, we can take h equal to 2 and convert all the values to 2, 2, 2, 2, 2. And we get all the 2s, so we stop. So this required 3 operations. But if you see here, this step was redundant. We could have directly taken 2 because there is no value between 2 and 4. So we will try to take the minimum so that we reach towards k. So in this case, we can do with just 2 operations. First time convert all the 5s to 4 and next time all the 4s to 2. So in this case it's 2, but let's say k is equal to 3. So if k is 3, then this conversion is not possible because we have 5, 2, 5, 4, 5. So all the values larger than 4 are 5. So we convert everything to all the 5s to 4. And now k is k is 3 in this case. So here h was 3, h was 4. Now we can take h equal to 2 or 3. So if we take h equal to 3, this will become 3, 2, 3, 3, 3. Now still all the values are not equal to k. So we will take h equal to 2. So all the values will become 2, 2, 2, 2, 2, 2, 2. So all the values are never becoming equal to k, that is 3. So in this case, we will return -1. So how do we solve it? So let's visualize. There are some numbers here. This is some value and some more values. So this is denoting some value. Let's say 10. This is some another value 7. There are 3 10s. There are 4 7s. There are some maybe 1 6. and then there is some value k. So some numbers may be equal to k, there may not be any k present in this case. So let's say there are some k's and there are some values less than k. So if this is the case, as we saw here, k was 3 and there was some number which was less than k. So we are only decreasing the value. So we will never attain k because we cannot increase this to reach this. Our goal is that all the values should come to this level. So these are different levels. But we are allowed to decrease the values but not allowed to increase the values. So these values which are less than k will never reach here. So straight away we will return -1. But if let's say this is not the case, good case, then uh, there are only 3 levels above k. So that is the minimum number of operations, because in first operation you will pick any valid value from this range. In fact, you should pick the previous level so that it becomes equal to that. So that will minimize the operation. So first you downgrade all these values to this level. Now this level is gone. You have 2 levels above k. Now next time you downgrade all these 7 to 6. Now you have just 1 level above k. Now you downgrade everything to k. So you have to just check what is our k and how many distinct values are more than k. And that's it. That would be the number of operations. Anything below k, you encounter return -1. So now let's write the code for this. And in this case, what we will do, number of operations can be, so how we will keep track of distinct elements? Just keep elements in a set, and set does not allow duplicates. So the size of the set will return distinct elements. You will not insert k, and as soon as you encounter anything below k, return -1. No need to even continue till end. So you need to just scan through this list once. So time complexity is O of n, space is O of n, since you are storing the numbers in a set, and in the worst case these may be close to number of elements, these unique elements. So now let's write the code for this. So in fact we don't need even size. So let's keep a set of integers and let's call it vals for int I in nums. If I is less than k, return -1. If I is more than k, then we will insert in the set. If it's equal to k, we don't need to insert it, since the values which are k are already k. So those k values don't need to be disturbed. And then if yeah, we can straight away return size of distinct elements. So vals dot size, and let's see. Yeah, so it works for all 3 test cases. Let's submit, and the solution is accepted. So I hope you understood this problem. So see you in next video.